Hi friends, today we're talking about the Pythagorean Theorem. Now you may have heard this word before or about this before, but today we're going to dive into what it is, why it is a little bit, and kind of get to the basics of the Pythagorean theorems. Now, Pythagorean is named after a mathematician way back when named Pythagoras. Discovered the pattern, came up with the piece, and then theorem and what a theorem is. So a theorem is something that's been proven mathematically to be true always. So if it's proven, it always works, it becomes, or it's mathematically proven to become a theorem. So we're going to talk about the Pythagorean theorem. It's important to note that the Pythagorean theorem works for right triangles. Right triangles and right triangles only. Okay, right triangles only. So if we don't have a right triangle, this idea is not going to be true. It's not going to hold up. So we want to make sure if we have a right triangle, Pythagorean theorem does apply. This is going to be a little bit of a longer video, so make sure you stay with me. Take a break if you need to, but all the information here is going to be really important. So first, let's take a look at some right triangles. Here I have a right triangle. I'll zoom in here. It's a right triangle because it has the right angle in it. So it tells us it's a right triangle. We always want to look at that before we go to use the Pythagorean theorem. This right triangle is unique in that it has a side length of 3. We can see those 3 boxes. And then this side length is 4 units. So that's why we have the 4 there. I'm going to notice a pattern here. I'm going to draw a square off of each side. Now, if it's a square, it means all sides are 3. So I have 3, 3, which makes 9 total boxes, or 3 squared. So I have 9 boxes there. I'm going to do the same on the bottom. But this time it has a side length of 4 because that triangle side had 4. So 4 here, and so on, which is going to give me 16 boxes when I make the square, right? So here I took 3 squared, makes 9. 4 squared, or 4 times 4, makes 16. So what about this other side? Well, I'm going to use another piece of paper here. I'm going to line it up, and we're going to notice that it has a length of 5. 1, 2, 3, 4, 5. And if I square 5, 5 times 5, I get 25. Well, there's a unique pattern here. Take a look. 9 plus 16, if I add those two together, I get 25. Interesting. Let's look at another right triangle. Now, same thing. Now I have a side length of, I should put a little mark in there, right triangle. I have a side length of 6. So if I made a square off of it, 6 squared, I would get 36. And on the bottom I have a square, but it had a length of 8. So 8 squared, 8 times 8, makes an area of 64. Now, 36 plus 64 makes 100. If I look at that side, and I line up my boxes vertice to vertice, I have a length of 10, which is interesting because 10 squared, if I make the square on it, 10 times 10 is 100, which we said these two values added up to. So that's the pattern that Pythagoras, the mathematician long ago, discovered. He said, okay, if I make these squares off the sides, I get the same amount of area as the square off that other side. And that's what the Pythagorean theorem tells us. So we're going to use that to use a formula called the Pythagorean theorem. So first we're going to talk about the Pythagorean theorem in right triangles. So let me zoom out here. This is, oh no, I can zoom out a little bit more. Here we go. Pythagorean theorem. The Pythagorean theorem works for right triangles. So the first thing we have to know is we have to have this right angle. If we don't have the right angle, we can't use this pattern that we just talked about. Let's talk about parts of a right triangle. The two sides of the right triangle that form the 90-degree angle. So they meet together at the 90 degree. These are called legs. They're the legs of the triangle. Think L, for leg, they form the L in the triangle. So I have A and B. Those are just variables. They could be any variable we want it to be, but typically in Pythagorean theorem, we see them as letter A and letter B. So the legs form the 90-degree angles, or the L itself. The long side. Now look, this is important to note. A couple things to identify a hypotenuse. It is across from the 90-degree angle. It will always be across from the 90-degree angle. So the 90-degree angle opens up to the hypotenuse, we call this. The hypotenuse. The hypotenuse has a characteristic that it is always the longest side of the right triangle. This is important to know because if we just had numbers of side lengths and we didn't have a picture, we would always want the largest number to represent the hypotenuse. The hypotenuse is often denoted with the letter C. So C usually stands for hypotenuse, but again, it could be any variable really. So what does this tell us? How do we use these parts and these ideas? Well, we can use them in that formula we pretty much discovered on that graph paper. It says if I take a leg, call it A, right? So I took this leg and I build a square off of it, or I square that number. Remember, we built squares off the side. If I take that number I get and I add it to the other leg's square, so I build a square going this way, that number that I get when I add those together will be equal to whatever this number is squared. So if I built that square off of the hypotenuse, it would equal that value. And we saw that. I'll give you an example again. This leg squared, 9, A squared, plus this leg squared, or B squared, 25, makes 25, equaled C squared, or 5 squared, which was 25. So that shows that pattern holds true. And that is the Pythagorean theorem. Just to recap, let me zoom out, that A squared plus B squared equals C squared. Leg squared plus other leg squared equals hypotenuse squared.